So today modules are polymorphism. Okay. So you will be concentrating what exactly polymorphism. So already we have discussed that there are some unique features of CPP, right? CPP are OOPS concepts, right? Hello,
Sir, yes,
who is there?
Ranjit, sir.
Yeah,
Sir,
yeah. One can respond. Okay, so that I will have a
okay,
better move. Okay, yeah. So basic features of OOPS concept series. అందరు పంపించండి అందరూ పంపించండి కదా కంటెంట్ అందరికి మామూలు ఫస్ట్ పంపించండి డ్రాప్ బాక్స్లో అదే 7 8 డ్రాప్ బాక్స్ ఫస్ట్ డే పెట్టాం కదా ముందు చూడు డౌన్లోడ్ చేసుకో మారలేదు మనం పంపించా అది వాళ్ళది కదా మనం ఓన్ వీ హ్యావ్ అవర్ ఓన్ కదా వీ హ్యావ్ అవర్ ఓన్ డ్రాప్ బాక్స్ నా క్రెడెన్షియల్స్ కూడా ఉంది చూడు మెయిల్లో ఉంది చూడ ఎంఎస్ఐటి ఎంఎస్ఐటి అని చెప్పి ఉంది మెయిల్లో ఉంది చూడు నీకు పంపించిన మెయిల్స్లో ఫైండ్ ద కంటెంట్ ఇన్ డ్రాప్ బాక్స్ అని ఉంటుంది లింక్ కొట్టు డ్రాప్ బాక్స్ కొట్టు వస్తుంది data abstraction, right? Encapsulation, inheritance, polymorphism. Able to view this? Hello?
yes, sir, yes,
Yeah, are able to see the notepad? Notepad?
yes, sir.
Ah, exactly. Yeah, exactly. Right. So you can keep response so that I can move properly.
Okay, sir.
Yeah. So as we discussed in the first session itself, there are basic features of OOPS is data abstraction, encapsulation, inheritance, and polymorphism. Right? So we can provide the data abstraction and encapsulation through a class as well as access specifiers. So data abstraction in sense hiding the information, right? And encapsulation. Encapsulation is a process of wrap-up of both data and members into a single unit that can be called as a class. Okay, that can be called as a class. When coming to the inheritance, inheritance is nothing but a child class is going to inherit the properties from base class. Okay, child class is going to reduce the LOC by inheriting basic properties which are common to all other classes. Okay, so indirectly we are going to reduce the code or not.
Yes, sir.
So yesterday, whatever the experiment we have done, whatever the task we have done, we have achieved the inheritance concepts as well as we are able to do the inheritance. We are able to implement the inheritance concept, right?
Yes, sir.
Yeah. And when coming to the last one, polymorphism. Poly means many, morph means forms,
Forms.
many forms. Okay, many forms. In this polymorphism concept also, again, indirect message is code reusable. Okay. Here also we are
Okay, sir.
having. We will use another record, not that. అది తెచ్చుకోండి అది వద్దులేండి దాని మీద వద్దు ఫోల్డర్ తెచ్చుకోండి ఇది బాగాలేదు అది వద్దన్నారు కదా సార్ ఓకే సో poly means many morph means forms many forms okay
Okay, sir.
yeah so today we are going to concentrate on the polymorphism and relevant tasks okay you can see so are able to see my browser now
Yes, sir. Yes, sir.
yeah one can read it here module 7 polymorphism are able to view this
Yes, sir.
okay okay fine no problem so module 7 polymorphism and here learning objectives here is By the end of this module, you will be able to explain polymorphism, explain the significance of white pointer, use the following, implement late binding in C++, late binding or runtime. Early binding in sense static. Okay, there are two,
Okay.
there are different
Okay.
terminology here actually. So runtime and compile time, right?
Yes, sir.
Sometimes we can say instead of compile time early binding, instead of runtime late binding. Okay, binding
Okay,
means
sir.
binding means assign the values to variables. We are binding. Bind means just making the making the relation actually, making the relation actually. So that is called exactly binding. Late binding means after compilation, if the values are going to be assigned during the runtime values. When you are giving to values to the particular variables, by that time that can be called as a runtime. Okay, so that is exactly called as a late binding. Late binding is equivalent to runtime. And a base class pointer is a pointer to derived class. The virtual keyword to declare the virtual member functions and explain the concepts of binding, define late binding, state the need for late binding, explain the significance of virtual functions, define a pure virtual functions, define an abstract class, and you are able to write C++ programs using abstract classes, define the following concepts like static polymorphism and dynamic polymorphism. So these are all the basic learning objectives out of this session. Okay. Identify overloading as an implementation of static polymorphism. Identify the late binding as an implementation of the dynamic polymorphism. Differentiate between static and dynamic binding. Okay. So and we are also use a virtual destructor. Okay. So if you can see still other points, still more points. Okay. So here, as we mentioned, the introduction of polymorphism is the ability to associate more than one implementation with the same operation. The binding of the operation with the implementation can be decided at the compile time or at runtime. In object orientation, polymorphism can exist in two ways: hierarchy independent and hierarchy dependent. So when coming to the hierarchy independent, this takes the form of overloading, and where the same name of the operation has different implementations in different classes, and these classes need not to be related by class hierarchy actually. When coming to the hierarchy dependent, here an operation is defined in the superclass can have any number of implementations along with the class hierarchy. This type of polymorphism is referred as a universal polymorphism or overriding. The operation can be bound to any of the implementations. This solution can take place at compile time or runtime. Okay. So any interruptions? Okay. So there are two types of polymorphism here. We can implement function overloading and function overriding. Okay. So when coming to the pointers, addresses and pointers, the ideas behind the pointers are not complicated. Here is the first key concept here is every byte in the computer's memory has an address that you know actually. Addresses are numbers actually, just as they are for houses in the street. The numbers start at 0 and go up to from here 1, 2, 3 and so on. If you have 1 MB of memory, the highest address is, see, this is the maximum value of the address for the 1 MB of memory. Okay. So your program when it is loaded into memory occupies certain range of these addresses. That means that every variable and every function in your program starts at the particular address. Do remember that, as we have already worked with pointers, right?
Yes,
Hello?
sir.
Yeah. So pointer is a variable which can store the address of the another variable, right? Yeah.
Yes, sir.
So you do remember that the address is having instruction, the address is having the address of the function, whatever it may be. So we can also refer the pointer variable wherever required actually. Okay.
Yes, sir.
So here the concept is pointers to wide. Before we go on to see pointers at work, we should note one particularly of pointer data types. So ordinarily the address that you put in the pointer must be the same type of the pointer, isn't it? So you cannot assign the address of the float variable to the pointer to int. So data type should be very important here when we are working with the pointers. Okay. Okay. Yeah. So here the small program. So float flavor 98.6 int star printf equal to, so here there is a some value ptr int equal to ampersand flavor. So this is a invalid. This is invalid because float value here is flavor value is float type, and we are indirectly what we are doing is we are assigning the integer pointer to the flavor variable. So whose type is float actually. So which cannot be acceptable. That's why it will give you an error. Okay. So this is one condition you should remember. Okay. However, there is an exception to this. There is sort of general purpose pointers that can point to any data type. Okay. So this is the why we are assigning pointers to wide instance. Suppose there is some exception in the pointers. That exception can be, suppose if you are pointing some value to the float type or some other type, pointer should be the same type. It shouldn't be another type. So in order to avoid that, so we will be having very generic pointer that can be called as a wide pointer. So if you can see here, wide star pointer, ptr can point to any data type. Okay. So this is called wide pointer, which can point any data type irrespective of data type. Is it clear?
Yes, sir. Yes, sir.
Yeah, yeah. And such pointers have certain specialized uses, such as passing pointers to functions and that operate independently of the data type pointed to. The next example uses a pointer to the void and also shows that if you don't use void, you must be careful to assign pointers to an address of the same type as the pointer. Here is the listing of ptr void. So ptr void.cpp, you can see this is the program hash include iostream using namespace std int main. You can take it as a program. Okay. Then int variable, float, float variable, int star, print int, okay, define pointer to int, float variable, ptr float, void, ptr void, print int, ptr int equal to ampersand int var. This is valid. This is valid. And ptr int equal to ampersand flavor. It is an error because data type is different. And ptr flow equal to ampersand int var. Int var. So it is also wrong because ptr flow is a float data type pointer, but we are assigning integer address of the integer actually. It is also not valid. Okay. So ptr flow equal to ampersand flavor. This can be acceptable. And ptr wide equal to ampersand int var. It can be accepted, right? ptr wide equal to ampersand flavor, which can be accepted. So it is a what is the point? It is wide pointer. These two are the wide pointers. Okay, wide pointers are generic pointers which can refer, which can point any data type, any kind of data type which can refer. Okay, so this is the fragment of code which will demonstrate the importance of the wide pointer. You got it or not? Yes, you
Yes,
got
sir.
it or not?
Yes, sir.
Yeah, it's so here is one more program. You can assign the address of int var to ptr int because they are both type integer data type, but you cannot assign. Okay, same concept is covering here. So print equal to reinterpret underscore cast int star flavor. So you can also use this actually. You can also use this. suppose suppose here the thing is for the lines. So you can see. So if for some unusual reason you really need to assign one kind of pointer type to another, you can use the reinterpret cast. This is the C++ keyword which you can use. This is the C++ keyword reinterpret underscore cast. For the lines commented out pointer wide, that would look like this. So print equal to reinterpret underscore cast int star flavor. Generally flavor is a float data type, right? Flavor is a float data type, right? Say yes or no?
Yes, sir.
Yeah, we can cast it using this keyword. We can cast it with this keyword using reinterpret underscore cast. Okay, ptr
Yes,
flow
sir.
equal to reinterpret cast float star int var. This is also valid. Sometimes if you are not using the white pointers, this is also valid. To remember, this is also valid. Okay. The use of
Yes,
the
sir.
reinterpret cast, the use of the reinterpret cast in this way is not recommended, but occasionally it is the only way out of the difficult situation. Static cast won't work with the pointers. Old style C cast can be used, but are always a bad idea in C++. Okay, anyway, this is traditional methodology for casting the one data type to another data type actually. So anyway, this is one alternative is saying. Okay, then base class pointers. In C++, a pointer of a base class can point an object of its derived class. In example given below shows that what happens when the base class is derived class. All are having functions with the same name, and you access these functions using pointers. Here is the listing of base point. So now we can see base point.cpp. So using so there is a starting statement and using namespace std, and here base class public. In that base class public, so what are the methods? Void show cout base, void show cout base, and again close that base class, then class derived one, it is derived from base class. In the derived class again void show, then derived to here also void show. So what does it mean actually? So in this case, in this program, simple program, what are the structures? So there are one base class, two derived classes, right?
Yes, sir.
Yeah. But unfortunately, all the classes are having a common method. Void show, void show, void show, isn't it?
Yes, sir.
Yeah. So int main. Now when coming to the main program, you can see int main derived one dv1 object derived class in derived two dv2. So we are just creating the objects. We are just creating the objects. So derive one dv1 object derived class 1 dv derived 2 dv2, we are just instantiating the object 2, and here base star ptr. So this is the pointer to the base. Now you can see ptr equal to ampersand dv1, put the address of the dv1 in pointer, that is ptr. See, this is the symbol arrow mark, ptr arrow mark show. Now you can see which can be executed here. Which method will be executed here? Can you predict? Which method will be executed? The show method is from which class? Base class or derived one class or derived two class? Can you guess? This pointer pointing to which method? Derived class method, derived class one method, derived one or derived two or base?
Base.
Derived one. Here we are assigning the pointer to dv1, right?
Okay.
Right?
Okay, sir.
Yeah, that's why it will refer that derived one show method. And when coming to the second one, so put the address of d1 into pointer. So here if you can see, put the address of dv2 pointer 2 and execute show. If you can see this, ptr equal to ampersand d1, put the address of the d1 into the pointer. If reinterpret cast derived 1 star ptr is not equal to 0, then pdv1 equal to reinterpret cast derived 1 star ptr, pdv1 show. Okay. And ptr equal to ampersand dv2, put the address of dv2 in a pointer. If reinterpret cast is in pointer is not equal to 0, then you can use the same as above. pdv2 equal to reinterpret cast and into, this is casting mechanism, derived 2 star into ptr. So pdv2 hyphen and then this arrow mark show on return. So this is exactly basic pointer, null pointer concept, void pointer, object oriented programming. It is available, you can download, or you can see the content from this c++.com site. Reinterpret cast and dynamic, you can see the both links. So this is one of the best sites for C++, where you will be having all the illustrations. So here you can see, before getting into this section, it is recommended that you have a proper understanding of pointers and class inheritance. Already we know, right, what exactly pointers and class inheritance, right? If any of the following statements seem strange to you, you should review the indicated sections. Int a colon b of int c, classes a, this is pointer notation, right? Data structures, class a, public b. So friendship and inheritance, pointers to the base class. So this is one example. You can see. Now you can see this example. Let's go with this example explanation. Hello?
Yes, sir.
Yeah. Yes, sir. All are there?
Yes, sir.
Yes, sir. Yeah. So using namespace std, I will do this.
పోలీస్ సిస్టమ్ మన ఇది సీనియర్ బ్యాచ్ వాళ్ళ రిజిస్టర్
So pointed to the base class example. So class C polygon. Class C polygon. There is a one polygon class. Okay, protected. So for polygon here we are taking two data members, width and height, and methods can be set values as well as get values actually. Public void set values int a comma int b, width equal to a, height equal to b. Probably you may understand this code, this fragment of code, right? Able to understand this code? What is being done here? Hello? What is being done here? Class C polygon protected under protected int width and height. There are two data members, they are namely width and height, which are required for this class. And when coming to the method, void set values of int a comma int b. So already, yeah, int a, int b is the values from the external, that is user is going to pass these values, right? And width and height are the local variables to this class. So width equal to, we are assigning the a value to width, we are assigning the b value to height. Yeah. So this can be a simple method, set values method, which is going to set the values of height and width, which is taking the values from the external input. Then class C rectangle, public C polygon. So one more class. This can be derived class, right? This is a derived class. Say yes or no? Yeah. Class C rectangle colon public C polygon. So it is taking the properties from the C polygon, and it has one more method, int area. So it has a method called int area, and it should be defined here itself, written width into height, because whose return type is integer. Okay, and fortunately it is capable to invoke the values from the polygon class. Width and height is available from the polygon class. So as it is a protected specifier can give the values to derived classes, right? Yeah. So the scope of protected variables is protected members is which will give the values to derived class also. So we are directly returning, taking the width and height from the C polygon class and multiplying these two and returning to the called one. So that's why return width and height. Then class C triangle colon public C polygon. It means what? One more derived class. Okay. C triangle is also deriving the properties from C polygon, and it is also having area, written width and height by 2. So if we can see this class, these three classes, okay, the first one is a base class, right? Yes or no? Yeah. The second class is the derived one, let it be. The third class can be derived 2. Yeah. So the C rectangle class is derived from polygon class. C triangle class is also derived from C polygon class. So these two classes are inheriting the properties, that is these two are sharing the members of width and height of the base class, that is C polygon class. Up to this clear? And one more confusion here is C rectangle class is also having the method area. C triangle class is also having the method area. Okay, here the ambiguity will come across. Okay, so here ambiguity will raise. Okay, so now we have to resolve it properly. So for that, this example is given actually. Okay, so up to this clear? Say yes or no? All of you are clear with this up to this? Gayatri, say yes or no? Bhanu Prasad, yes or no? Bhanu Prasad, okay. Uma, where is Uma? Uma, you didn't submit deliverables. Hmm? Where are you actually yesterday? You didn't come across yesterday. But it is your responsibility to inform, right? Before that. So you didn't. Hmm. Hmm. So what about your deliverables? Okay. Anyway, so let us go to this. So up to this clear? Whatever we have discussed so far. So are you able to see the screen, programming screen? Yeah, okay, fine. Now, and uh, and coming to the main program, let us see the main program. So int main, C rectangle rect. Okay. So we are just creating the object of the rectangle. C triangle TRG1. So L triangle TRGL. That will be TRGL. Here rect. Rect is the object of the C rectangle class. TRGL is the object of the C triangle class. Now you can see C polygon into PPO P poly 1 equal to ampersand rect. So here this is nothing but pointer. This is nothing but pointer. C polygon pointer P poly 1 equal to ampersand rect. C polygon, this is the C polygon pointer P poly 1 equal to rect, and C polygon pointer P poly 2 equal to ampersand TRGL. So indirectly what we did is we are just we are addressing, we are creating the C polygon pointers, and for them we are just assigning the address of the rectangle object as well as triangle object. Is it clear? Clear or not? Yeah. Yeah. P polygon, so arrow mark set values of 4 comma 5. So what happens here? So P polygon 1 arrow mark set values. So in the set values in the which class actually? Rectangle class. Set values is a method which is available at the rectangle class. That is derived class 1, right? So we are just calling that method by passing the values. That is 4 comma 5. Set values 4 comma 5. Then what happens actually? The values will be set to the set values method, isn't it? And width and height will be set for that, right? Isn't it? 4 will be added to which variable? Width. 4 will be added to width. Okay. 4 will be added to width. 4 will be, this is 4, this is 5 actually. 4 will be added to width, and 5 will be added to height. Isn't it? Yeah. Then. So P poly 2 set values of 4 comma 5. That is for the second instance. second one poly to triangle. For triangle also, so these values will be added, and set values p poly 3. Again we are using this poly means what? What is this poly? Poly is a object. Which object? Base class object. Right or not? Isn't it? C polygon poly. This is the object of the base class. So for base class also we are assigning the values 4, 5, 4, 5. Now you can see we are just printing the values. C out P poly area, P poly 2 area, P poly 3 area, written 0. Okay. So here if you can see, so P poly 1 20, 4 into 5, 4 into 5. Okay. And P poly 2, why it is 10? Any idea? Can you guess why it is 10? Anyone can tell me why it is 10?
20 by 2, sir.
20 by 2 exactly. So as per equation, it is computing and giving you the value. Okay. Yeah. So when coming to the P poly 3, why it is 0?
Return 0, sir.
Yeah, written 0. So there the equation, area equation written 0. Is it clear now? Yeah, exactly. So this is exactly one example under pointer, right pointer. Okay, right pointer to the base class. This is an example. Okay, then let us switch over to the task. You can see. So everyone understand this? Say yes or no?
Yes, sir.
Is it clear? Gayatri, Ramkrishna, Ranjit, Sandeep,
Yes, sir.
Uma. Uma, are you
Sir.
there?
Yes, sir.
Okay. So problem set A. Let us discuss the problem sets. Okay.
Okay.
Uh, so when coming to the problem set A, create a set of classes of shapes, triangle, quadrilateral, circle with the following inheritance relationship. So this is the document actually where you will be having the hierarchy that you can download and see. Declare and define the classes as shapes. So in these shapes, abstract base class, shapes can be a abstract base class, triangle, abstract derived class with base class as shapes. So this is another triangle. So like this, 1, 2. So under triangle, these are the another derived classes you can have. So here attribute with two sides, again attribute with one side. Here this is one attribute, and quadrilateral abstract derived class with the base class as a shapes. And here in the, under quadrilateral again there are three: rectangle, square, and rhombus. And under shapes one more thing is circle. So this is derived class from the shapes. Okay. So here shapes under shapes triangle is sub, under triangle these two are the sub, again quadrilateral under this these are the sub. Like that you can create a hierarchy, right? And circle derived class with the base class as shapes, attribute with the radius. Attribute in sense parameter, what parameter you need to add, that is nothing but attribute here. Okay. Use the following declarations for the abstract class and test the main function. Write the code wherever necessary. Okay. So now you can see this using namespace std class shapes. So it is a abstract class, abstract base class, and class and public. So here you can see virtual double get area, virtual double get parameter, virtual void get data, virtual shapes. This is just destructor, right? So calculates the area and returns the area, calculates the perimeter and returns the perimeter, take input from the user and store the state of the object. Okay, and these are the, see, abstract class is having no implementation, only definitions are there actually. Okay, do you know about abstract class? Abstract class has only definitions, only declarations, there is no definitions. Okay, so class triangle public shapes. So triangle is going to inherit the properties from shapes. The code is given, you can implement whatever the required here. Okay, yeah. So this is the first task, and display menu interface to the user, create an instance of the object. The main program should have this kind of menu. Okay, yeah, this is the expected output. Display a menu interface to the user to create an instance of the object. The menu should be like this: create an instance of triangle, instance of betty triangle, quadrilateral. Under triangle you can create these two, under quadrilateral you can put this. Okay, so you can add constructors for the derived classes with default values. Okay, so create, this is, so create, you can create the instance of the derived classes selected and then call the get data function. The class and store the instance in the array of shapes. Do remember, write a test main function to take the input from the user for all the shapes and store them into an array, then print the area and perimeter of the classes. So here you will be having some link, okay, related to the shapes and all the measurements in the centimeters, that you should remember. You can name it as a pa1 underscore shapes. Okay, yeah. So this is morning schedule. Okay, so I think it is right time to start. Okay, so we will be discussing in the second module in the afternoon session, not now. Okay, so you can finish it by morning session itself. Okay, is it clear now? Say yes or no.
Yes, sir.
So will you start this?
Sir.
Yeah, right. So go ahead, and we'll start it here. I will record this and share it among other whoever not attended this session. Okay, go ahead.